Welcome dear all to this online lecture on the flexible connectors, that is belt drives and chain drives. So these are called as flexible just because they can be wrapped around a pulley or the sprocket, and they can take the shape of the pulley or the sprocket. So their shape is not rigid as we had seen in case of the gear drives. Now what is a belt drive? So belt drive is a power transmission system in which the motion can be transmitted from the driving shaft to the driven shaft with the help of belt which is wound around the pulleys. One pulley is mounted on the driving shaft, whereas the other pulley is mounted on the driven shaft, and both are separated apart with some distance, and with the help of the belt this motion is transmitted from the driving shaft to the driven shaft. We can see here in this image. So first thing, we need to understand why we need the belt drive, because we already have a very good power transmission system in case of the gear drives. So the applications in which the gear drives are not useful, then we have to use the belt drive. For example, when the environment is dirty and dusty, or when the fluctuation of output speed will result into the gear failure, then we can't use the gear, so we have to use some other mode of transmission media, and the belt drive is a good one. Then when the long distance between the power transmission is required, that is the driving shaft and driven shaft are some distance apart, then we cannot use the gear drive. Similarly, we can't use the gear drive in case of the chemically active environment, so that the gear which is made up of metallic structure, that will get corroded away or rusted away. That's why we can't use that, so we have to use the belt drive in that case. Now next thing, factors affecting the amount of power transmitted. So for that we have to consider various factors, that is what amount of power is required to be transmitted. Based on that we will choose different type of transmission media in case of belt drive, that is whether we are going to use flat belt or V belt or so on. So first is the velocity of the belt. So for the moderate amount of power transmission or the lower amount of power transmission, we have low velocity of the belt, and for low velocity of belt we can use the flat belt. Similarly, the tension under which the belt is placed on the pulley, that is also an important factor while considering the which type of which type of drive is to be used, or what amount of the power is to be transmitted. Similarly, the arc of contact between the belt and the smaller pulley is a very important factor here. We will discuss this later on, that what is the arc of contact. The conditions under which the belt is used, as we had discussed in the previous slide, that the conditions are important. Similarly, the points to remember while designing the belt drive. First point is maintain the uniform tension across the belt section, because if the tension is non-uniform, then that may result into the stress concentration zones across the cross section of the belt, and that may lead to the elongation of the belt at that cross section, as well as it may cause the failure of the belt. The pulley should not be too close together. So remember, this is very important factor, because if pulleys are too close, means the power transmission is as at a closer range, then instead of belt drive we could have used gear drive. As we had discussed earlier, that the power transmission with the help of belt drive is mainly used for the longer distance power transmission. Then the arc of contact on the smaller pulley should be as large as possible, because the belt is wrapped around pulley, and as much as the angle of contact or arc of contact on the pulley, that will increase the frictional grip between the belt and pulley, as the belt drive is a friction drive, so friction plays an important role in case of the power transmission with the help of the belt drive. So arc of contact is very important in case of the belt drive designing. Similarly, the pulley should not be so far apart to cause the belt to weight down on the shaft, because the pulley itself have its own weight, and that pulleys are mounted on the shaft. So the shaft has to carry the weight of the pulleys, as well as the weight of the belt will also be tra- transferred on the shaft, that is driving shaft and the driven shaft. And if the belt is too bulky, then that may cause the bending of the driving or driven shaft. So the weight of the belt should not be too high. And if the length of the belt is increased, then definitely with the increase in the length, the weight will also increase. So we have to consider this also. Then the tight side of the belt should be at the bottom. This is one thing we should remember in case of especially the open belt drive, and in case of the flat belt drive. We must have the tight side of the belt at the bottom. In case of the V belt drive, we can use the tight side either on the top as well as on the bottom, but in case of the flat belt drive, we have to use the tight side of the belt at the bottom only. So these are different types of the belts we can see from in the GIF over here. This belt, you can observe here, this cross section of this belt is a rectangular cross section. That's why this type of belt is called as flat belt. This flat belt and this both are flat belts. Then next is the V belt. This is the V belt, that is the cross section of the belt. You can observe from here the cross section of the belt is somewhat in trapezoidal shape. The third type is the circular belt. Circular belt is also called as the rope drive. So we can see here, if we see here, just observe that this shape of the belt is circular, or its shape is somewhat like a rope. That's why it is also called as rope drive. It is used in factories and workshops, the moderate amount of power transmission, and when the two pulleys in which the motion has to be transmitted should not be more than 8 meters apart. So this is the criteria for flat belt, that is the maximum power transmission distance is not more than 8 meters. It should always be less than 8 meters. So whichever is the case, you cannot transmit the power more than 8 meters apart. So from 2 to 3 meters to 8 meters you can transmit the power with the help of flat belt. Then next is the V belt. V belts are mostly used in the factories and the workshops, and it is also for moderate amount of power transmission. It is also useful for moderate amount of power transmission. And when the two pulleys are very near to each other, circular belt or rope drive is again a similar type of V belt drive, but there is some advantage with by using the circular belt. First thing, it is used in factories and workshop, and a great amount of power can be transmitted with the help of the rope drive. When the two pulleys are more than 8 meters apart, then we had already discussed that you cannot use in that case the flat belt drive, and in case of V belt drive we have to use the distance which is not more than 1 meter apart, 1 or 2 meters apart. So for less than 1 or 2 meter distance we have to use the V belt, and if the distance is up to 8 meters, distance between driving shaft and driven shaft is up to 8 meters, then we have to use the flat belt. And if the distance between the driving shaft and driven shaft is more than 8 meters, then we have to use the rope drive. One more thing we should know about the V belt drive and rope drive is that multiple belts can be used together in case of V belt and rope drive. So we can increase the power transmission from driving shaft to driven shaft up to by using many layers of these belts, means multiple belts. So each belt have a different power transmission capacity. As much as the number of belts you are going to increase, then that will increase the power to be transmitted. So for higher power amount of power transmission we can use the V belt. by multiplying the number of belt, or we can use the circular belt or rope drive for high amount of power transmission. As the numbers increases, so simultaneously the power transmitted through each rope is getting multiplied. So if huge amount of power is to be transmitted, a single belt may not be sufficient. Then wide pulleys for V belt or circular belt with the number of grooves can be used to, you can increase the number of grooves on the pulleys, and in each groove you can accommodate a V belt or a rope, and that will increase the power transmission capacity of your drive. Then material selection of the belt. The material is the most important thing for a belt drive, because we already know that it is a type of friction drive. That is, the friction between the belt and the pulley surface will lead to the power transmission. So the friction is the must thing. So material selection should be such, material selection of the belt should be such that it should have high coefficient of friction between the belt surface and the pulley surface. So materials for the flat belt are either leather, cotton fabric, rubber, or mostly the rubber is used in almost flat belt as well as V belt to increase the coefficient of friction. Synthetic materials, canvas, etc. Similarly, for the V belt, fabrics and cords molded in the rubber can be used. Materials for the circular belt or rope are cotton, steel, hemp, manila wire, and similarly few cotton ropes impregnated with the rubber can also be used in case of the rope drives. Then the selection of belt drives. Factors to be considered in case of selection of belt drive. Available space. It is one of the most important criteria while selecting a belt drive. So a large distance power transmission is required, and the space availability should be high. So in that case you can either use the flat belt drive or the rope drive. So availability of the space is one of the most important criteria, because if motion transmission or power transmission should be at a smaller distance, then we have to use the V belt drive. If it has to be at a larger distance and the availability space is more, then you can choose either of these. The distance between the two shafts is also very much important. As we had discussed earlier, the ratio between the speed ratio between the two shafts, that is the speed at which the driven shaft has to be run and how much speed is available at the input shaft, that is the driving shaft, or how much rpm the driving motor is running. So we have to decide on how much speed is to be transmitted with the help of the belt drive, because we had seen that for higher amount of speed, high speed transmission, we cannot use the flat belt drive, because a flat belt drive has to be used at a moderate amount of speed. Belt speed is also important criteria, as we had seen earlier. Power to be transmitted, as for moderate amount of power transmission we have to use the flat belt drive or V belt drive, but for a great amount of power to be transmitted we have to use the rope drive. Service condition and the climate. So based on the service condition and the climate, we have to choose specific materials of the belt as well as specific materials of the pulleys, so that under the given service conditions they should not get corroded or should not get fell apart. Then types of belt drives. So these are different 8 types of belt drives. We will see one after the other. Open belt drive. So in case of open belt drive, we can see here in the figure that the tight side is on the lower side and the slack side is on the upper side. So what is the tight side or what is the slack side? So driving pulley, this is, you can see here, it is a driving pulley. It pulls the belt from one side and it releases the belt on the other side. So the side on which it is pulling the belt, it will get tightened up, or the tension on that side is increased. That's why this is called as tight side. And it releases, the pulley releases the belt on the other side. So here the belt is somewhat getting slacked, or the tension on that side is somewhat lower as compared to the tight side. That's why this side is called as slack side. So we need to all remember the tight side, what is the tight side and what is the slack side, because it will be useful in the entire chapter. You can observe here the driving pulley is here, and this is the driven pulley. So also you can observe that driving pulley, it is rotating in the clockwise direction here, as well as the driven pulley is also rotating in the clockwise direction. So in case of open belt drive, we can understand that the direction of rotation of the driving pulley and the driven pulley are same. Now next one is the crossed or twisted belt drive. So just observe here, this is the driving pulley and this one is the driven pulley. The driving pulley is rotating in the clockwise direction and it is pulling the belt from this side. So from the lower side it is pulling the belt and it is releasing on the other side. So on the lower side, the belt which is there, it has more tension as compared to the other side. That's why the belt on the lower side is tight side and it releases the belt on the other side. So that side is slack side. So what is the tight side and what is slack side, we need to remember in case of both flat belt drive and the cross belt drive, open belt drive and cross belt drive. So one more thing you should observe here, that the direction of rotation of the driving pulley is clockwise here, but the driven pulley is rotating in anti-clockwise direction. So in case of cross belt drive, the direction of rotation of driven pulley is opposite to that of the driving pulley. Then quarter turn belt drive. The quarter turn belt drive is used when the axis of the driving shaft and driven shaft are perpendicular to each other. So in that case you can't employ directly the belt from the driving pulley to the driven pulley. So in that case we have to use the quarter turn. One thing you should remember in this case is the weight of the face of the pulley, that is the driving pulley as well as the driven pulley, it should be more than 1.4 times of the width of the belt. Here you can observe 1.4 times of B means 40% increase of the pulley width should be there over the width of the belt. Then quarter turn belt drive with guided pulley. If pulleys cannot be arranged as seen earlier, then we have to use an increase guide pulley or an idle pulley, so which can be used to guide the belt from the driving pulley over the driven pulley, as well as to change the direction of rotation of the driven pulley. The guide pulley or the idle pulley can be used. Here again there is with the help of idler pulley, in case of in open belt could be used. So to increase the angle of lap or angle of the belt over the pulley, or to increase the surface area contact between the belt and the pulley, we can use an idler pulley. So you can observe here, this idler pulley is causing a depression on the belt over here, which increases the contact area between the pulley and the belt over here as well as over here, as it is a friction drive. So increase in the surface contact will increase the frictional grip between the belt and the pulley, as well as this can be used to because sometimes the belt length is more. So if belt length is more, then the belt is quite loose and it is very difficult to transmit the motion from driving pulley to the driven pulley, because there is a lot of slippage present. Then in this case we can use the idler pulley to increase the tension in the belt. As the tension is increased, so tight side on the tight side and the slack side on both sides, the tension can be increased, and with the increase of the tension, the frictional grip between the pulley and the belt will get increased, and that will cause the good amount of motion transmission with reduced slippage. just the same things we had discussed here. To obtain high velocity ratio, just to obtain the high velocity ratio, because slippage, if it is reduced, then the velocity ratio can be increased. So to transmit the motion from one shaft to the several shaft, again we can use the idler pulley. You can observe here, one is idler pulley, other one is here idler pulley, this is also idler pulley, this is also idler pulley. So motion is transmitted from this single driving shaft. The motion is getting transmitted to 1, 2 and 3 shaft. So 3 shaft can be driven with the help of only a single driving shaft or a single driving pulley with the help of multiple idler pulleys. The idler pulleys are the pulleys which are just to obtain a specific shape of the belt without transmitting the motion, because they are mounted on the loose shaft which are not connected to some driven shaft. It is just mounted on the bearing on some loose shaft. That's why these are called as idler pulleys, because they are not used to transmit the power. So motion, the power is transmitted to only 1, 2 and 3 shaft over here. You can see here on this GIF image how the multiple pulleys are run with the help of a single driving pulley. All the 1, 2, 3, 4, 5 and 6 pulleys are running, whereas 1 is the driving pulley and all remaining 5 pulleys are the driven pulleys. Compound belt drive. When the power is transmitted from one shaft to the other shaft through number of pulleys, then this type of arrangement is called as compound belt drive. So in many cases this can be used. One thing is to increase the velocity ratio. Other thing is, if the distance between the driving shaft and the driven shaft is too large, so we need to incorporate inbuilt an idler pulley arrangement in between, so that the motion can be transmitted from the driving shaft to the driven shaft, and without increasing too much the length of the belt, we can use a compounding system. So here you can observe, this is a driving pulley. There is an intermediate arrangement over here. Here the smaller pulley is driven with the help of this driving system. So this is one system in which the driving pulley is driving the pulley number 2. Then pulley number 2 and pulley number 3 are coupled here. Here pulley number 3 runs at the same speed as that of the pulley number 2, and they will pulley number 3 is connected with the help of belt drive to the pulley number 4. So pulley number 3 is driving pulley number 4 here. You can observe here. So pulley 1 drives pulley 2 and pulley 3 drives pulley number 4. So this type of system is called as compound belt drive. You can observe here multiple belt arrangements, even though the input is single. Here is the motor. So the motor is driving other drives, this motor is driving other drives, and all the belts are running with the help of a single input motion. There are multiple output motions we can get with the help of compounding system. Stepped or cone pulley drive. So to change the speed between the driving shaft and the driven shaft, stepped or cone pulley drive has to be used. So if the driving pulley is having lower radius, then and the driven pulley is having the higher radius, then definitely lower pulley runs at some speed, but the driven pulley runs at a smaller speed. If the radius of the pulley at the driving side is higher as compared to the driven side, then the speed on the driven shaft will be increased. So this stepped pulley can be used to achieve different velocity ratios between the driving shaft and the driven shaft. So stepped pulley, one thing you always should be remember that you can't change the belt. So the belt size should remain constant, and the design of the pulley should be such that the belt should not be changed for achieving different velocity ratio. Fast and loose pulley drive. So what is a fast and loose pulley drive? The driving pulley is a larger pulley having a higher width, and the driven shaft is mounted with two pulleys. One is keyed to the driven shaft. So whenever the belt is in contact with this keyed pulley, then with the running of the belt or the rotation of the pulley, the shaft will rotate. One more pulley is mounted over that shaft or over the driven shaft, and that pulley is mounted with the help of bearing. So when this pulley, that is called as loose pulley, if that pulley is rotated with the help of the belt, just because the presence of the bearing, that pulley itself will rotate, but it won't rotate or it won't drive the driven shaft. You can observe here from this video. I will show here. Just observe here, the belt is running on the pulley. Now here, even though the belt is running at the same speed, but this shaft is not running. Just observe here again, the belt is again rotating, and pulley is also rotating, but the shaft only the pulley is mounted, it is not rotating. So in this case, here it is the fast pulley, it is fastened with the shaft, and the other pulley, in which the belt is right now in contact with this fast pulley, and this one is called as loose pulley. So I hope you would understand what is fast pulley and the loose pulley drive. So right now we'll stop here, and then we will continue in our next lecture. Thank you.